Hi, welcome to Technical and Engineering Academy. This is Blessed Elvis. Okay, so the Cramer's rule is simply a rule we use to find the values of the unknowns given the simultaneous equation. However, this only includes the matrices where we use the determinants to find the values of the unknown values given in the simultaneous equation. So it's important that we understand how to find the determinant before we proceed into finding the Cramer's rule. So let's look at some concepts that you might find interesting. So here you are given a given simultaneous equation. So the first thing to do is expressing it in form of a matrix. So we know that a matrix, let's say, let me give a 2 by 2 matrix. A matrix is a given value of components in brackets in such a manner as the one shown in the diagram there. So here, to find the determinant of this, you multiply the major diagonal, which is in form of A and D, you multiply them, and then you subtract the minor diagonal, which is B and C here, rather B and C. Okay, so in this case, when you multiply this, we're going to have AD minus, when you multiply B and C, you're going to have BC. So whatever value you find here is your determinant. So a determinant is found by multiplying the major diagonal and then subtracting the multiplication of the minor diagonal. So let me give an example. So let's say you have 2, 3, 4, and 5. So the major diagonal in this case, to find the determinant, the major diagonal is 2 and 5. So you're going to multiply 2 and 5, you subtract. Then this time you multiply with the minor diagonal, that is 3 and 4. Okay, so in this case then, 2 multiplied by 5, we know it's 10. And then subtract there, 3 multiplied by 4, it's 12. Then 10, we subtract 12, we are going to have negative 2. So this is our determinant. So this is how we find the determinant. You multiply the major diagonal and then subtract the multiplication of the minor diagonal. Okay, so let's now go into finding the Cramer's rule now that we have understood how to find the determinant of the given matrix form. However, that's different from a 3 by 3 matrix. We are going to look at how we find that with time as we keep on answering different questions. So by now, let's start with a 2 by 2 matrix so that when we understand from this, then it's going to be easier for us for a 3 by 3 matrix. So let me give an example of a simultaneous equation. Let's say you have been given 3x then plus 4y equal to negative 14. And then also have, let's say, negative 2x minus 3y equal to 11. So when you have been given such a simultaneous equation, the first thing you have to do is expressing this in form of a matrix. So let's say you have, so for this simultaneous equation that we have, we first have to write the given coefficients of the variables. So the given coefficients of the variables are 3, 4, negative 2, and negative 3. So in this case, these are the values that you have to write in form of a matrix according to their position. So in this case, we're going to have 3, 4, negative 2, and negative 3. And then here, you write the variables that are present in the given expression. So in this case, in the order. So since we have begun with x, it means we are going to begin with x here. If we had started with y, it means we could have started with y. So since x is the one that has begun, it means that you are going to begin with x there. So then here you write whatever you have at the equal sign. So this is the standard form of writing the given simultaneous equation in matrix form. So after you are done with this, you are done with this, what you have to do for you to find the value of x, the way it is you find the determinant with respect to x, and then you divide the determinant of the general given matrix. So what you have to do here, for you to find the determinant for the x value, you have to replace here where there are these values here, you replace with this answer here. Okay, so you're gonna have negative 14, 11, and then you write whatever you have here, that is 4, and then negative 3. After you are done with this part, okay, let me just wrap this. Let me just wrap here. Hopefully you have copied somewhere so that you don't get confused. After you are done with that part, then you divide the same expression for the matrix, the general matrix that you had, which was 3, negative 2, and then 4, negative 3. Okay, so this is how we write the standard form for the matrix. Now, after you are done with this, you find the determinants of the numerator and the denominator, then you divide. After you divide, then whatever answer you have is for x. So since this time we have replaced where there are those values with this, for y you simply replace the here. Okay, so let me find the value for this. So x. So now what is the determinant of the numerator? So by now we understand that it's the major diagonal, that is negative 14 multiplied by negative 3, and then you subtract the minor diagonal, the multiplication of the minor diagonal, which we know of course is okay, hopefully you bear with me, just be copying the values. I don't want to remove this for the sake of explanation. So in this case, then we're going to have 4 multiplied by 11, and then divide. So this is the determinant for the numerator. So the denominator, we will multiply also the major diagonal, that is 3 multiplied by negative 3. Then we subtract the minor diagonal, that is 4 and negative 2. So it's 4 multiplied by negative 2. So let's find the values of these. Hopefully that you are following. So all you have to do is write in the values. Okay, so when you are writing the values, it's gonna be okay, because I'll be removing these from time to time for the sake of space. So in this case then, we are going to have x equals to, so what is 14 multiplied by 3? So 14 multiplied by 3 is 42. Now we have negative and negative, so negative multiplied by negative is positive, so we are going to have 42 here, and then here we have negative here, it's just negative, so minus 4 multiplied by 11, it's simply 44, over, down here we have 3 multiplied by negative 3, so negative 3 multiplied by 3 is negative 9, and then we have negative multiplied by negative, which is on the 2 side, we are going to have positive, and then 4 multiplied by 2, of course we know it's 8. So in this case then, we are going to have 42 minus 44, it's negative 2, over, so in this case then, what is negative 9 plus 1? It's negative 1. So in this case, negative and negative will cancel, and then we divide 1 into 2, we are going to have 2. So this is the value of x. So the value of x is equal to 2. Now remember, our matrix form was what? Was 3, negative 2, 4, negative 3, and then here we had x and y equals to negative 14 and 11. So for us to find the value of of x rather, we had replaced these values with what we had here. So for us to find the values of y this time, we will replace with this, we will replace this with what we have here. So let's do that. So in this case then, our value of y for the determinant, we are going to have 3, negative 2, and then we remove this, we write this, we're going to have negative 14, 11. Then down there we are going to write the general matrix, that is 3, negative 2, 4, negative 3 here. Okay, and then let's find now the determinants for these matrices that we have. So on top there, let's multiply this multiplied by that. So 3 multiplied by 11 is 33. So 33 minus, what is 14 multiplied by 2? Okay, it's 28. So negative multiplied by negative is positive. So then 2 multiplied by 14 is 28. So we're going to have 28 up there. Then over, then 3 multiplied by negative 3, it's negative 9. Then minus here, what is 4 multiplied by negative 2? We're going to have negative 8. Okay, so that's it. So let me just rub here, since we don't need this anymore. So remember, our value of x we have found is 2. Okay, so let's do that. So in this case, let's finish up. So y equals to, now 33, we subtract 33 minus 28, it's going to be 5. And then negative 9, negative, and negative, it's what? It's positive. So we have positive 8 there. So we have 5 over, what is negative 9 plus 8? It's negative 1, since negative is on the bigger number. So then negative 1 into 5, we are going to have negative 5. So in this case then, x equal to 2, and then y equal to negative 5. So these are our values. So let's look at one more last example for the 2 by 2 matrix. So what about if you have, let's say, x plus 2y equals 4. And then here you have 3x minus 5y equals to 1. How can we find the values of x and y using Cramer's rule or the determinants? So the first step is expressing this in form of a matrix. So we know this is going to be what? 1, 3, 2, negative 5. And then here, since it's x which is at first, so we are going to write x and then y here. Then equals to, here we are going to write what? 4 and 1. So these are our values for the matrix. So for us to find the value of x, we have to replace where there is this with that. Okay, so let's do that. So in this case then, we are going to have, hopefully we can write here. So on top there, we are going to have, where there is this, we will write this, that is 4 and 1. And then we will write 2 and negative 5 here, over. Then down there, we're just going to write the same matrix that we have here. So it's going to be 1, 3, and then 2, negative 5. Okay, so after we have written in this format, let's now find the determinants. Okay, so let me just wrap the top part here, since we don't need it anymore. Okay, however, we are gonna need it when we want to write the value for the y. So in this case, then we are going to have x equal to, so the major diagonal is 4 and negative 5. So 4 multiplied by negative 5, we're going to have negative 20, and then we subtract 2 multiplied by 1, it's simply 2 here, over. Then down there, we're going to multiply 1 with negative 5. Of course, it's simply negative 5. Then we subtract 2 multiplied by 3. We're going to have 6. So in this case, what is negative 20? We subtract 2. So we're going to have negative 22. Over. Down there, we have negative 5 subtracting 6. We're going to have negative 11. So in this case, negative and negative will cancel, and then 11 into 22, we are going to have 2. So this is our value for x. So let's also find the value for y. So we had 1, 3, 2, negative 5. And then here we had x, y equal to, here we had 4 and 1. So in this case, Since we had replaced here for the values of, or rather for the value of x, this time we are going to replace here with this. So let's do that. So y will be, so this will just be 1 3, and then here we are going to replace with what, 4 and 1, over here we are just going to write this matrix here, the original matrix, which is 1 3 and then 2 -5 here. So let's find the determinants for these. So in this case then we are going to multiply the major diagonal, that is 1 and 1 here. So 1 multiplied by 1 is simply 1. Then we subtract 4 multiplied by 3, it's simply 12. And then here we have 1 multiplied by -5, we are going to have -5. Then subtract 2 multiplied by 3, we are going to have 6. So in this case then, what is 1 subtract 12? We are going to have -11 over -5 minus 6, it's -11. So we can see that when we divide, okay, let me just maybe write it here. So we have -11 here over -11. We divide negative and negative there, and then 11 into 11 is simply 1. So in this case then, our value of x is 2, and our value of y is what? Is 1. So these are our values for x and y. So hopefully that you have gotten the concept when it comes to a 2 by 2 matrix, how we find the values of the unknowns using the Cramer's rule. Now let's go and start finding the values of 3 by 3 matrix. So a 3 by 3 matrix is quite complicated, so let's just follow up. Okay, so for this one, when you have been given 3 variables, okay, let me just be explaining this with an example. So we have, let's say we have 3x plus y minus 2z equals to 4. And then here we have negative x, then we have positive 2y, then we add to 3z equal to 1. And then here we have 2x plus y, then plus 4z equal to -2. So this is a 3 by 3 simultaneous equation. Yeah. So for us to find the values here, we have to express it in form of a matrix like we were doing before. So let's do that. So in this case we are going to have 2, -1, and 2 here, and then here we're going to have 1, 2, 1, and then here we're going to have -2, 3, and 4. Okay, so after we are done with this, remember in order of whatever you have here. So in this case we have x, y, and z, okay, equal to what? Equal to the values 4, 1, and -2. Okay, so these are the values we have for the matrix format. So let's remove this. So these are the values that we have. So the first step here is finding the general determinant. So just like we were finding for the 2 by 2 matrix, even here, to find the value of x, you find the determinant of, when you replace here with this, you find the determinant, and then you divide by the general determinant, which is for this matrix here. Okay, let me just write d there, and then for y, this time you replace here with this. Okay, so with that, so we are going to have the determinant for y over the general determinant. By the way, the general determinant is just the same, so if you just find it once, there is no need for you to find again. So z here, of course, you find the determinant for the z after you replace this with this. Okay, you find the determinant, and then divide the general determinant. So let's find the general determinant. Now, how do we find the determinant for a 3 by 3 matrix? So make sure that you understand that part, like how we find that. Make sure that you revise. However, hopefully from my explanation on this, it will give you an insight on how we find the determinant of a 3 by 3 matrix, because I will go step by step. Anyway, I will try by all means to go step by step to make sure that we follow up. So let me find the general determinant for this. So I will just write this and then get rid of this for now. So in this case we had 3, negative 1, 2, 1, 2, 1, and then negative 2, 3, 4. Okay, so to find the determinant of this, okay, let me just write a D here to represent the general determinant. You multiply this. Okay, you follow the rule of where we have positive, negative, positive, negative, positive, negative, positive, negative, positive. So the positive of this you multiply with that, the negative of this you multiply with this and that, the positive of this you multiply with this here. Okay, you will follow up, don't worry, you will understand. What I mean is, these, let's say these are the values you have been given. So the value which is here, okay, the positive value which is here, you multiply with this matrix here. So this will act as a scalar, and then this will act as a matrix. Okay, after you are done with that, you come here, you multiply this with the value of this matrix and this matrix, you put them together. Okay, and then after you are done with that, you come to this one, you multiply with this matrix here. So it's just the opposite. So in that line in which that value is, you don't have to find the values. So let's say in this line you won't find the values of this, you rather find the values of this. And again, likewise in this line you have to find the values of this and not the values of this. Also in this line you have to find the values of this. Hopefully that you have followed up. Now let's apply this concept so that you have an insight of whatever nonsense I'm talking about here. So in this case then, here we have these 3 here. So remember, here it was positive, negative, positive. Let me just take that part here since we are just dealing with the first row. So in this case then, we are going to multiply 3 with which matrix? Of course it's this matrix. Hopefully you can remember. So it's going to be 2, 1, 3, and 4. Okay, and then here is what? Negative. So negative of what? Of 1. So negative of 1. So in this case we are going to have what? Negative 1. We're going to have 2, 3, and 4 here. Okay, and then followed by what? Positive. So positive what? 2 here. Now here it has to be positive 2, but remember this 2 here has a negative. So since it has a negative, we are going to multiply this negative with positive here, which of course is going to give negative. Hopefully you will not be disturbed when I write negative here, because this negative is coming from the multiplication of the 2 signs, the 2 negative signs. So in this case then, I'm going to have negative instead. So negative what? Negative 2. Hopefully you understand this is positive, but instead we are going to write negative 2 because here it's negative. Okay, so for this one we are going to write with these ones here. So it's going to be negative 1, 2, and then 2 here, and then we have 1. So this is our first step. So after you have expressed it in this, you have expressed the given matrix in this form. By the way, even for the determinant of x and y, you do likewise. So in this case, let's proceed now. So in this case, we're going to have d here equal to, so we are going to have 3. So here, you have to find the general determinants. So the determinants of these 2 by 2 matrices that we have inside there. So of course, hopefully you have the general concept from the previous examples we have gone through on the Cramer's rule on the 2 by 2 matrix. So in this case, we are going to have what? The major diagonal, that is 2 multiplied by 4. So 2 multiplied by 4, okay, 2 multiplied by 4 is 8. So 8 minus 3 multiplied by 1 is what? 3. So we have that. Then here we have minus 1. We also find the determinant for this. So negative 1 multiplied by 4, it's negative 4. and then minus 3 multiplied by 2, it's what? It's 6. So we have that. Okay, and then here we have negative 2. Then negative 1 multiplied by positive 1, here it's what? Negative 1. Then 2 multiplied by 2, it's what? 4. So we are going to have negative 4. So let's simplify this. So the determinant for this one is equals to 3. And then here we are going to subtract. So 8 minus 3 is 5. Okay, and then minus 1 here. And then negative 4 subtract 6 is negative 10. Okay, and then we have negative here. And then negative 1 subtract 4. We are going to have what? Negative 5. So these are the values we have this far. So let me just get rid of this. Let me just remove this. So hopefully you are following. So in this case then, the general determinant is going to be 3 multiplied by 5 is what? It's 15. So we have negative 15, or rather positive 15, and then negative here and negative is positive. Then 1 multiplied by 10, it's positive 10 there. And then negative and negative, it's what? It's positive. And then 2 multiplied by 5, we are going to have what? 10 there. So in this case then, our general determinant is going to be 10 plus 10 is 20, and then 20 plus 15 is what? 35. So this is our general determinant, 35. So make sure that you take note of this so that you keep it somewhere, because you're going to need it later in this video for us to find the values. So this is the general determinant. So let's also find the values. So in this case, remember our general determinant, or rather our general matrix was 3, 1, negative 2, 3, 4, and then 2, 1, negative 1, 2 here, and then here we had what? X, Y, Z, and then here we had 4, 1, negative 2. So this was our general matrix, and then we have also found the determinant of this. So this time we are going to find the determinant for what? We are going to find the determinant for dx. So dx in this case, it means that where there is this, we are going to remove it and then write what we have here. So in this case, we are going to have 4, 1, and then negative 2. Then we write whatever we have here. So that is 1, 2, 1, negative 2, 3, and 1 here, rather 4. Okay, so this is our matrix. So since we have already done this, go ahead and find the determinant for this using the same procedure that we had done before. Okay, so that you assess yourself, you see how far you have understood. Okay, so in this case, to find the determinant, of course by now we know, so dx is going to be, so this time we're going to multiply this with this matrix here, so it's going to be 4, and then we're going to form 2, 1, 3, and then 4 here, then minus here, of course we have minus, so here it's 2, it's 1, so it's 1. So in this case we're going to multiply with this and that, so the matrix of 1, negative 2, and then 3, and then 4 here. Okay, and then here it's positive, so positive multiplied by negative here, it's going to be negative 2, and then here we have what? This here, that is negative 1. Is it negative? No, it's positive. Okay, it's simply, okay, it's 1. Rather, let me move the negative, so it's 1, then negative 2, and then we have what? This one, which is 2 and 1 here. Okay, so let's proceed to find the determinant of the 2 by 2 matrices we have in the brackets there. So here 2 multiplied by 4, it's 8. So 8 we subtract 1 multiplied by 3, it's what? It's 3. And then minus 1 here, 1 multiplied by 4, it's 4. And then negative 2 multiplied by 3 here, it's negative 6. So in this case then, minus 2 here, Okay, then 1 multiplied by 1 is 1, then negative 1 multiplied by positive 1, rather negative 2 multiplied by positive 2, it's rather negative what? So here we had, was this negative? Okay, okay, this one, it's negative 2. So negative 2 multiplied by this, it's negative 6. But remember, here we have the negative, so it's going to be negative here. We generally subtract, when we multiply 4 with 1, it's 4, and then minus. But here we have a negative, that's why I've written another negative there, just like here. So we have 1 multiplied by 1, it's 1, and then negative 2 multiplied by positive 2, it's negative 4. So we have that. Okay. Okay, rather let me reduce the font, so we have that. Okay, let me just wrap this. We have a lot of the stuffs here, so hopefully you are following up. So in this case we have dx equals to 4, and then 8, we subtract 3, we have 5 here, and then minus here 1. Okay, and then negative and negative is positive, so 4 plus 6, it's 10. Okay, and then minus here we have negative 2, and then here negative and negative, we are going to have positive, and then 1 multiplied by 4, it's what? Or rather 1 added to 4 is 5, so we have 5 there. So dx in this case is going to be 4 multiplied by 5 is 20, and then here negative 1 multiplied by 10 is 10, then negative 2 multiplied by 5 is 10. So in this case then, what are we going to have? We are going to have 0, because 20 subtract 10 is 10, then 10 minus 10 is 0. So our dx is what? Our dx is 0. So you also keep that. Now remember, our general matrix was 3, negative 1. Okay, let me just write that properly. Was 3, negative 1, and 2. And then here we had 1, 2, 1. Then here we had negative 2, 3, 4. Okay, so we will find this up to, okay, we are going to find this up to the zip. So here we had this equal to, sorry for that. So here we have 4, 1, and then negative 2. So in this case, since we had replaced here to find dx, for us to find dy, this time we are going to replace here. So in this case, then our matrix will be what? 3, negative 1, 2. So this, we subtract that, we're going to have 4, 1, rather not negative 1. Here we have negative 2, and then you write this, that is negative 2, 3, and then 4 here. So that is our matrix. So go ahead and find its determinant. Okay, so in this case then we have that. So let's find dy. So dy is going to be these 3 multiplied by all of these here. What are we going to have? So we are going to have 3 here, and then 1, negative 2, and then 3, and 4 here, and then minus, this time we have 4 there, so it's going to be 4. We multiply with what? With this and that. So what are we going to have? Negative 1, 2, 3, and 4 here, and then this time we come to this. So here it's positive, so positive multiplied by negative, it's negative 2, so it's negative 2 multiplied by these values here. So we are going to have negative 1, 2, 1, negative 2. So that's what we have there. So let me just remove this in advance, since we have already expressed it in such form. So in this case, let's simplify this. So let's find the determinants of the matrix. Says that we have, so 1 multiplied by 4, it's simply 4, then minus negative 2 multiplied by 3, it's negative 6, so we have 6 there. Okay, and then minus 4, then negative 1 multiplied by 4, it's negative 4, and then 2 multiplied by 3, we are going to have what? Negative 6. Okay, then minus 2 there. So negative 1 multiplied by negative 2, we are going to have positive 2. And then minus 2 multiplied by 1 is simply 2 there. So in this case, then our dy is going to be 3. And then negative and negative is positive. So 4 added to 6 is going to be 10. Then minus 4. Then negative 4 minus 6 is negative what? 10. Okay, and then negative 2. Then 2 subtract 2, it's 0. So in this case, then let's simplify that further. So 3 multiplied by 10 is 30. Then negative and negative, it's what? It's positive. Then 4 multiplied by 10 there, it's what? 40. So we have 40, and then minus 2 multiplied by 0 is simply 0. So in this case, when we add this, okay, when we add that, we are going to have dy equal to, so 40 plus 30 is what? Is 70. So in this case, then our dy is 70. So make sure that you keep this. So make sure that you are keeping these values because we're gonna need them. So let's find also dz, the last one. So remember our matrix was, so I am rewriting this because if I just simply write the value direct, we might be confused. So it's better that I write this so that you are also getting the concept of where I am getting the values from, instead of simply direct going to writing the value. So you may go ahead, of course it's just the same thing, so you may go ahead and find the value. So this time, for us to find gz, we are going to replace this with that. So we are going to have 3, negative 1, 2, 1, 2, 1. So where we have this, we are going to replace with this. So it's going to be 4, 1 there, and negative 2. So this is our matrix. So we may simply go ahead and find the value of the determinant for this one. So let me wrap there. Okay, so we have that. Let me remove this. Okay, so in this case, then our gz is gonna be, so this 3 multiplied by whatever we have here, what are we gonna have? 3, and then we have 2, 1, 1, negative 2. Then here we have positive, so rather negative, so negative multiplied by 1, here we are going to have negative 1, and then here we have negative 1, 2, and also 1, and negative 2. And then here we have positive, we have what here? 4. So it's going to be 4. Then here we have this, that is negative 1, 2, and then 2, and what? And 1. Sorry, that's not 12, and this is not 21. Those values are separate, but for the sake of space, I am going to write them like that. So make sure that you take note of that. Those are not values for 12 and 21. It's negative 1, 2, and positive 1. Those are matrices. Okay, it's just for the sake of space that I've written it like that. Okay, so in this case, then let me just wrap this. The font is just too much. So in this case, we are going to have gz equal to 3. So in this case, it's the positive 2 multiplied by negative 2. We are going to have negative 4. And then minus here, 1 multiplied by 1 is simply 1 here. Then we subtract negative 1 multiplied by negative 2 is positive 2. Then minus here, 2 multiplied by 1, of course it's just 2. Alright, then positive 4 here. Then negative 1 multiplied by 1, it's negative 1. And then 2 multiplied by 2, it's 4. So we have that. So let's simplify this. So gz is going to be 3. And then negative 4, subtract 1, we're going to have negative 5 there. And then negative 1. Then 2 subtract 2, it's simply 0. Then plus 4. Okay. Then in this case, negative 1 and negative 4 is what? Negative 5. So in this case, we're going to have gz equal to 3 multiplied by negative 5, it's negative 15. And then negative 1 multiplied by 0 is simply 0. And then negative multiplied by positive, we're going to have negative. Then 4 multiplied by 5 is what? 20. so we have negative 20. So in this case then, negative 15 minus 20, we are going to have negative 35. Okay, so our dz in this case is negative 35. So dz equals to negative 35. So now we have found the values of the general determinant, dx, dy, and dz. Hopefully you are taking note of the values. So in this case, to find the value of x, let's find the value of dx, of x rather. So it's going to be dx here over general determinant. So what was our dx? So our dx was 0. So divided by 35, of course we are going to have 0. Then our value of I, it's dy here over general determinant. So our dy was what? Was 70 over general determinant, which is 35. So 35 into 70 is what? It's 2. And then our value of z was dz over general determinant. So dz was what? Was 35. Rather, it was negative. So let me just write negative 35 over the general determinant is 35. So 35 into negative 35, it's negative 1. So these are our values of x. So x is equals to 0, y equals to, rather x is not 0. Yeah, x is 0 and then y 2. Then our z is negative 1. So these are the values.